Hey guys, can you believe this? This is going to be the last set of notes for Chapter 4. It's gone so quickly. So I'm going to combine two chapters together, or two lessons together, 4-7 and 4-8. And the reason why is basically it's the same set of rules as we did in lesson 4-6 when we're dividing, and we're dividing by a fraction of any kind. So this is just lessons 4-7, 4-8, and we're just going to call it dividing fractions. Or dividing with fractions. How about that? And today's date is going to be 10/8/18. So let's recap very quickly the notes from before. So first, we need to have two fractions. So the two scenarios that we might have is we may have a whole number, which we're going to go ahead and convert to a fraction. So as simple as having 4 becomes 4/1. And then the other situation would be mixed number. And we would convert it to an improper fraction. So let's say we have 3 and 5/6. In order to get the improper fraction, we multiply the denominator times the whole number, so 6 times 3 is going to be 18 plus the old numerator, not plus, 5. We'll do it over here, plus 5. The denominator stays the same at 6, so we get 18 plus 5, and we get 23/6. Okay, so you have two fractions. And then as we get ready to prep the problem, we're going to change it from a division problem to a multiplication problem. So we have three components to the division problem. We have the first fraction, the division symbol, and the second fraction. And we're going to keep the first fraction the same. So we're not going to do anything to it other than what we've already done in step 1. Now we're going to change to multiplication. So we're going to change the operation. So change the division symbol to a multiplication symbol, or you can use the dot to represent multiplication. And notice it's in the middle, not low. And then we're going to write the reciprocal, of the second fraction. Now I can go and explain to you why this is a process we use, but it's pretty complicated. So just trust me on this one, that this is the way that it needs to be. And just to a reminder that if I'm asking for a reciprocal, we're just going to take the numerator and denominator and switch places. So 1/2 would be the same as 2/1. And again, if I want to take the reciprocal of a mixed number, I have to first change it, as I've already done in step 1, to an improper fraction. So 4 times 1 is 4 plus 3 is 7. That's equals, and then I would take the reciprocal and I would get 4/7. And then, just like we would do with multiplying, we're going to try to pre-reduce. I know some of you are not really trying this step, but one way or the other, you're going to have to do some reducing, whether it's before you multiply and then make your number smaller, then multiply and then check your answer, or afterwards. So try to pre-reduce, and you're going to cancel out common factors that you see. Then you're going to multiply straight across. And then the last thing you're going to do is to see if the answer needs to be reduced. Now again, by reducing, I mean dividing out a common factor. Okay, so let's go ahead, and we've got 4 examples for you to do. So I'm going to go to my next screen. And again, remember, pause it whenever you need to. So our directions are just going to say divide. And I know that sounds weird because we end up multiplying, but that's just the way it goes. So our first one, we have 1 3/4, and we want to divide it by 2/5. So remember, when I'm giving you examples, not only are you understanding what the directions are asking you to do, you're also understanding what the work should look like. Remember, we like to work in a vertical fashion. So job 1, I have an improper fraction, or mixed number, so I need to change it to an improper fraction. 4 times 1 is 4, plus 3 is 7. So I get 7, try that again, fourths, divided by 2/5. Okay, now I'm going to go ahead and keep 7/4 the same. Division becomes multiplication. I like to use the dot. And then I'm going to take the reciprocal of 2/5, which is just 5/2. So I look on my diagonal, 7 and 2, nothing. 5 and 4, nothing. 7 and 4, those are now the individual fractions. 7 and 4, nothing. 5 and 2, nothing. So I multiply straight across, and I get 35/8. Now, we've talked about this before. This answer is a perfectly good one as long as it's not a word problem. If, however, you want to convert it, remember it goes like this. The 35 is being divided by the 8. 8 goes into 35 4 times, which is 32, with 3 left over. And because we're doing fractions, we're going to leave the remainder as a fraction. So the 3 becomes the numerator, the 8 is the denominator. So this could be a secondary option. Okay, so the only thing that's different is we had to use a mixed number this time. All right, let's get 2 mixed numbers. 5.5 divided by 2.5. So we're going to convert both of those to improper fractions. 2 times 5 is 10 plus 1 is 11. 2 times 2 is 4 plus 1 is 5. Now we're going to rewrite this as a multiplication problem. We're going to keep 11/2 the same. We're going to convert division to multiplication, and then I have to do another change, and that's going to be the second fraction. I'm going to take its reciprocal, and I get 2/5. Now this time I do see I have some pre-reducing. 2 can go into itself once and into itself once. So I multiply straight across, and I get 11 times 1 over 1 times 5. And again, perfectly happy with that answer. However, if you want to change it to a mixed number, we're going to divide 5 into 11. It goes twice, which is 10, with 1 left over. So the answer would be 2 1/5 if I did it as a mixed number. Number 3, let's have a fraction being divided by a mixed number. Now, I know what some of you might be thinking right now. You might be saying, hey, can't I change get improper fractions and take whole numbers and make them into fractions and change it to a division problem all at the same time? And the answer is, yeah, well, you could. However, when you're doing too many things at one time, that's where you make careless mistakes. So I'm trying to avoid those. So 8 times 5 is 40, plus 5 is 45 over 8. 3/4 stays the same. Division becomes multiplication, and we take the reciprocal of the last. So again, we're doing 2 changes, the operation change and the fraction reciprocal. So I do see some things I can reduce out. 4 goes into itself once and into 8 twice. But here comes our friend Stinky 3. Yep. He goes into himself once and into 45 15 times. Look at how much nicer this problem is. I had to multiply 4 times 45 and 3 times 24 and then try to reduce that otherwise. So I have 1 times 2 is left in the numerator. 1 times 15 is 15 in the denominator. It's a proper fraction, so there's no other possible answer. All right, we'll do one more like that, but we're going to switch up and make the first number be a whole number, and then we'll divide by a mixed number. So first thing we do is make everything a fraction. 8 becomes 8 over 1. 2 1/2, 2 times 2 is 4, plus 1 is 5, becomes 5 halves. Now we're going to rewrite the problem. We're going to keep 8 over 1. We're going to change division to multiplication, and we're going to take the reciprocal of 5 halves, which is 2 fifths. And just when you thought you were going to have something to cancel out, when we did the reciprocal, it went away. So 8 and 5, there's nothing. 2 and 1, there's nothing. 8 and 1, there's nothing. 2 and 5, there's nothing. So we're going to just multiply straight across. 8 times 2 is 16. 1 times 5 is 5. And again, I'm good with that answer. However, if you want to write that as a mixed number, you're going to divide 5 into 16, always the denominator into the numerator. That's going to go in 3 times, which is 15 with 1 left over. So we could also have it as a mixed number, 3 and 1/5. 1/5. All right, there you go. Good luck tonight.